Thank you, Chris. Couple of things. We're probably sticking to the end time of the lunch, but probably not to the beginning time of lunch. So it will be cut, but it will look like it's not cut, I guess. All right. I want to repeat that the DMs, my DMs are open, so if you have anything to say to the crowd, you can say it through by proxy me. There were some people that reached out to me that they didn't like my singing earlier. I take feedback really seriously, so I will not be singing anymore. Oh, yeah, this is really nice. Okay, announcing our new speaker. She is a Rails Girls organizer and a Ruby friend and open source enthusiast from Uganda. She is the author of Python 2 and 3 compatibility book. And she came out of the Rails Girls Summer of Code program in 2016 and now works at Outreachy. And will tell us about the magic of containers and how we can all deploy our Ruby apps a lot better, robuster, better. So, Joannah, please.
Thank you very much. Like she said, my name is Joannah. I want to introduce myself more. But I would just say that I'm a friend of the Ruby community because I learned to program from a Rails Girls meetup, and that was my first language. So I love being here. So today we're just going to talk about containers in the context of Ruby. Containers are hot, but we're not talking about them because they are hot. We're talking about them because of their benefits they have for our applications. So we'll talk about the why, the what, and the best practices so that you use containers the good way without bad manners, being nice in short. So we'll start by what are containers, how do we containerize a Ruby application. I'm sorry for the people that are already experts. We'll go through a little background for the people that do not yet know. And then I'll put a lot of emphasis on how we create small images because in the good practices of working with containers, it's good that we have small images. And then I'll have a hint about how do we ensure we have testable containers. So, just to take you a little back, when we think about deploying Ruby applications, we usually have three things in our mind. It's either you're thinking about a physical machine that's at its core a server or something, or you think about a virtual machine, or in this era, you think about containers. So let's review. First, in that era, there was a time when deploying applications was literally an event. It was a ceremony, in short. So we basically deployed applications on a machine, and we ensured that a single host that we ensured one application per physical host so that nothing went wrong because it was an event and we wanted to ensure things stayed as they are. In other words, if we had a good deployment, we wanted to ensure that nothing breaks after that. But if you noticed, so regardless of how big your machine was or how great the features the host had, it ran one application, which was not good for the expensive computing resources we had on that one machine. So we needed a way to have multiple applications run on the same physical, expensive resources on the machine so that we are able to utilize all of them. So later, we adopted something called the virtual machines. So with virtual machines, we're able to, use the same hardware, the same host, and run multiple applications on it, separated with a guest OS, so we would have other guest operating systems running on the same host, and we would be able to run multiple applications. So in this case, we were actually able to virtualize the hardware and utilize all the resources we had, which was good, until we noticed that virtual machines took years to boot up. So we needed another way. We needed a way around that. How would we ensure our applications booted really fast? So the solution was containers. So what are containers? At its core, containers in normal languages, they're just storages for something. But also in software development, containers hold the same meaning. They're basically packaging or a sandbox for our application processes. So we logically package our applications to abstract them from the environment in which they run in. So the architecture in the container world is we basically virtualize the operating system. So we have the same guest OS, and then we run something like called a container engine, and then all our applications run on top of the container engine. There are many container engines you can use. I'll just be talking about Docker because, I mean, the variety, you can always choose whatever you want, but somebody told me it's not a good idea to finish a technical talk without mentioning Docker. So we'll talk about Docker today. I do not want to give the impression that containers are going to solve every problem we have. And there is still a place where virtual machines will always play their role. And like I pointed out a few differences, with virtual machines, we are basically virtualizing the hardware. We're running a guest OS on top of our host OS, and then we're running applications there. And with a container, we just run something called a container engine on top of our host operating system, and we do not need any guest operating system on top. So what do we get with containers is we're able to boot or start applications faster than its counterparts than in virtual machines. I would say virtual machines still have a role to play in system separation. Containers still have a role to play with application separation. So I wouldn't say that everything we use virtual machines for, maybe we can use for containers. It should be used with care. But with performance, if we take a minute to start a container, we may take an hour to start a virtual machine. That's exaggerated, but yeah, we get a bit of performance. So why should we even care about containers? Well, I just gave a bit of performance, but there are, I think, three big benefits that come with containers. First is portability. Deployment was a ceremony before because we needed to ensure reliability in production because software moves environments. It moves from our laptops and goes to production. So that's movement. But how do we ensure that there is consistency even when we move environments? We also needed to scale. Now, containers in themselves may not be able to scale, but this is my belief. They give us all the ingredients to scale. If you have your microservices and they're in containers somewhere, we are able to, if we think about scaling, we are in a good way. Now, if you talk about containers, I'll talk about the noble benefits of why we need to use containers, and Kelsey Hightower has many other dubious reasons that he can give you. He's talked about containers. But I think I agree with his statement, and he's always right, by the way. Okay, most times right. That the container image is just a packaging concept. Think of them as a price of admission to modern platforms such as Kubernetes. I think I share the same view. Containers give us ingredients to scale. When we containerize applications, we are able to use or make use of other good platforms like Kubernetes to be able to manage or scale better or manage better applications. So the whole concept of containers was, it came up with such good ingredients that would be able to later cluster very well, later scale, and the like. Okay, so what is containerization? In Ruby, there are 3 steps you'll follow with Docker to containerize your application. So the first thing you'll do if you have a Ruby application, it could be Sinatra or anything, is you'll create a Docker file. So a Docker file contains our instructions our instruction that we use for creating a containerized Ruby application. We'll specify how to execute our application and the like. And then from the Docker file, we'll create an image. So think about an image as a template from which we'll create many other instances of containers of our application. So a container is a given instance of an image of our application, which image we build from the Docker file, from the instructions we specify in the Docker file. So there are basically very simple 3 steps. You can always find details about how you can create a Docker file. There are very many examples all over the internet to do the same. So given such an example, this is a Hello World Sinatra application, just printing Hello World and its respective gem file. The first thing you need to do is create a Docker file. You specify a few commands. The first thing we need to do is specify our base image. In this case, we are using Ruby 2.3 Slim as our base image. You could use a normal operating system like Ubuntu as your base image. However, later you may need to install Ruby itself and other things. We can use there are very many other commands we can use in a Docker file. I think that's not the scope for today. There's great information on the Docker website on how to go about this. But we are basically specifying instructions on how to handle our application and execute it. So after creating the Docker file, you have to build an image from the Docker file and then run your container. And we basically use 2 steps. You just need to install the Docker client to be able to run those commands. So in summary, containers are packaging for our application. They give us portability, increase productivity, and give us a way to scale very fast, the ingredients to scale. And to create a container, given a Ruby application, you need to just create a Docker file, specify your instructions, build the image using a command that will build the image based on the Docker file we created earlier, and you start your container. Now, that's a summary of how you containerize a Ruby application. And I think you could actually be doing it right now, like in 5 minutes, if you can actually go through these steps. However, that's not all. That's something, but that's not all. I mean, you can containerize an application in a short time, but I think there are very many other things we need to think about. And the most important 2 things I just singled out that we need to think about when dealing with containers is performance and security. Performance, not because you have somebody on your team that checks performance, but things need to move faster. We also need to think about security, because there's a security engineer anyway. He has a bug, whether you fix it, it's a problem. Even if you don't fix it, it's usually a problem. So we also need to ensure that our applications are secure. And so how do we ensure performance and security for a containerized application? So the biggest secret, there may be other secrets, but the biggest secret is to ensure that we reduce the size of the resulting image. I already pointed out that we basically do installations and any other thing that are needed to run a Ruby application in the Docker file. So depending on the steps you do there, they contribute to the resulting size of the image you create. And how does the size of the image So one, with performance, the first thing you need to do is build the image. And if your image is big, it will take longer. We also push our images to like an image registry. You could use Docker Hub or the Google image registry. So we're pushing images and pulling images. And if your image is big, performance-wise, it will take either longer, depending on the size, in the operations of pulling and pushing images. Then for security, big images become an issue because there is a bigger surface area for attack. So the bigger the image, the bigger the possibility of being able to be attacked. I think you can just do a small exercise. There are tools. I think Google and Docker, I think Docker Hub has a feature where you can compare. Just give it 2 images and scan for security vulnerability. So a bigger image will usually have more cases for attack. So since the solution is to create a small image, let's explore some of the ways to create a small image when working with containers. The first thing, there are very many tricks. I'll just give a few tricks, and then you can always explore others. So the first thing you need to do is ensure you use a small base image. We'll talk about that later, but also install what you need, only what you need, so that you don't have a lot of junk that you're not using, then they're using up space. So here you're saving space, but also you're ensuring that your container will run faster. So I just want to take you a little bit back. This is a sample Docker file, and I'm using the Ubuntu, the latest version of Ubuntu as my base image, and then I have other instructions to install Ruby, create some working directories, and execute some commands. This Docker file works as file. However, when we compare the sizes of the basic available options you have for base images, you have like 4 if you're working with Ruby. You could work with the Ubuntu or any other Linux OS you have. However, the size is like 187 megabytes. And if you chose the Ruby Alpine, it would be like 55 megabytes, which is an improvement. And if you use standard Ruby as your base image, it's like 863 megabytes. And then if you use Linux Alpine, it's like 5.249 megabytes. So from this analysis, you see the smaller the base image you have, the smaller your resulting container. So I would say to improve this Docker file, the bad way is to use the Ubuntu. The better way is maybe use the Ruby Alpine, because it's smaller. But even better, you can improve the Docker file by using Linux Alpine as your base image. Because just imagine how many megabytes you will have saved yourself. The biggest is Ruby, so it's around 863, then you come down to 5, which is significant improvement. Now, Linux Alpine just gives you enough to run your application, but it's not good in all cases. There are times when it will require more development work because you don't have maybe all the libraries you need. And also, Linux Alpine has problems with standards and security we may never trust. So in some of these cases, you may choose to go with the standard Ubuntu version, but if you do not care for the tool, you may still, I think it's better to base on the smallest image, the smallest base image. Okay, then there's a command called run in the Docker file, and we use it to do very different tasks like updating stuff or installing software. And you can choose to have as many run statements in your Docker file as you can. However, this also increases the layers you have, and in turn increases the size of the image you usually have. So the best thing to do is, the bad way is have different run commands. The better way is chain your run commands. It also has significant gains to reducing the size of the image. So then also install just what you need. In Ubuntu, when you install things, you're given an option for minus no install recommends, so that you just install exactly the things you need for your container, rather than getting all the junk, or rather all the libraries that you actually don't need. So you can also make use of that, so that you just install what you need and leave out what you do not need. So another trick also is to clean up after yourself. So after installing whatever libraries you need, you can always clean up some of the directories, so that you clean up your container. And this also has significant gains in regards to the resulting size of the image you'll have. So these are just a few tricks that I've just shared. And if you want to know more about how to create more effective containers, Abby Fuller's talk at DockerCon 2017, she actually goes very in-depth about the different, even more tricks up on how to create a small container. So you can look out for her talk. Then the last thing to do is, containers need to be tested. Just like the way we do TDD or test-driven development for our code, we also need to drive the interaction of our containers. So first, there are 3 domains, basic domains, in how we can approach testing for containers. We can run some commands inside the container to see if they actually output the required output we expect from them, or we can also check for existence of specific files. If they're in the given locations, we can also actually check for contents of a file and in the file systems in the container itself. And we can also do metadata testing. And the good thing is that there are tools all over that we can use to do that. I've used the container testing framework from Google. I know there are other options. Again, it's a matter of choice. And just to wrap, containers give us benefits in portability, because we need to move environments. They give us ingredients to scale. In themselves, we may not be able to scale so perfectly, but they usher us into using better platforms like Kubernetes to help us do scaling and other things. And then creating a small image gives us benefits in performance and security. Then, just like you unit test your code, containers also need to be tested. Thank you. These are the resources you can always.
Thank you so much, Joanna. Is it working? It's not working. It works now. Great. Well, yeah. So, we have 1 hour, 15 minutes for lunch. It doesn't matter, they're getting up anyway, it's fine. It's just for you guys. That means we want you back at 1:30 here, please, yes? Okay. Some people, you can still get lunch at the hotel. You just have to go to the registration of the hotel to get a voucher.